Welcome to MEC 100 Introduction to Engineering Technology. Today we're going to talk about some of the different engineering/engineering technology disciplines that you may choose to get involved in. First and foremost, I'd like to say that engineering and engineering technology are very closely related. With that in mind, let's look at what an engineer is. Engineers are, first and foremost, they are problem solvers. They're individuals who combine knowledge of science, mathematics, and economics to solve technical problems that confront society. That's the definition from Foundations of Engineering from McGraw-Hill. So, with that in mind, they use math. They don't just put together pieces. They design those pieces. They know exactly how large that bracket needs to be, how tight that bolt needs to be, how large that wall needs to be, how big that footer needs to be, how large a wire is required to carry current safely in order to accomplish our engineering design goals. They also do so with economics in mind. It doesn't matter how great of an design that you have, if it's not economically feasible to be built, it simply won't be built. Except, of course, for those sort of things that exist outside of budgets. Things like the space program, in which we assume at some point in the future that our endeavors will pay off. And they have paid off uh, some in the past. Uh, Things that were developed for the space industry have found their way into our use every day. Certainly, the space industry has helped develop technology and telecommunications to an extent I doubt that it would have been at had we not had the space program. But back to engineering. Scientists' specific goal is to produce knowledge without necessarily regard to how that knowledge might be used. We're just sort of expanding our understanding of the universe. But it's an engineer's job to take knowledge and use that to produce things. So as soon as a scientist develops some sort of understanding of some phenomenon, an engineer is hot on their heels thinking, how can I use that to make my products better? To accomplish our design goals, we use what is known as the technology team. One of the roles in the technology team is the scientist, developing that information that is needed by the engineer to produce their designs. The engineer's role to create those designs. Uh, he or she may work with pencil and paper or computer models, probably a calculator, in order to determine size and shape and function of the things that we as a society need. But the implementation of those designs, the hands, if you will, of the engineer, that's the role of the technologist and the technician. The technologist has a slightly uh, larger role in maybe the design process, whereas a technician does a little bit more of the hands-on work. You, as an engineering technology person, will probably be slotted somewhere between technician and technologist. You may go on to get a 4-year degree, in which case you'll probably work as a technologist. Or you may stay with your 2-year degree and sort of work as a technician. By and large, though, wherever you work, the company, your boss, is going to look at the skills that you have and maybe slot you into roles that they think work best. So they may have you doing sort of the work of the technician or the work of a technologist or the work even of an engineer. The artisan is a very critical role in this technology team. Those are the machinists, the welders, plumbers, the masons, the carpenters that sort of build these things that we need as a society. Now you, again, as an engineering technologist, may be good with your hands and you may have some some background, some experience, some education, and work and fulfill some of the roles typically that are part of an artisan. Specifically, I know many of you are involved in advanced manufacturing or in mechatronics. In those cases, you may most certainly may be doing some work as a machinist or a welder as part of your duties. And if you're, show promise and do well, then I'm sure you're going to be doing some design work, which is typically the work of the engineer. I've I've listed these things in a, sort of a list, but you should in no way think that in some way a scientist is higher level than an artisan. It takes the entire group in order to make this all work. They're all links in a chain. Here are some of the types of engineering that you may be familiar with or may not be familiar with. And just like engineering, there is engineering technology that goes along with each of these fields. Now, there are other specializations that you may get involved with, such as automotive engineering. Well, we don't have automotive listed, but certainly if you work as a mechanical engineer, there's a good chance that you may choose to work in the automotive industry. You may be interested to work in petroleum engineering. Well, petroleum's not listed, but the processing of that crude oil into gasoline, diesel, heating oil, kerosene, whatever, is really the work of a chemical engineer. So even though you don't see maybe something that you're interested in listed there, I bet it's very closely related to something that's here. Let's start at the top with aerospace engineering. Now, aerospace involves the movement of structures and vehicles both within the Earth's atmosphere and outside the Earth's atmosphere. As an engineering technology person, you may be working with the engineer building test equipment or building models or testing those models for airflow, etc., taking data, maybe even helping analyze that data. In agricultural engineering, you may be doing soil samples and then treating soil either with fertilizers or with things that cut down or destroy weed growth to increase crop yield. Chemical engineering, that's a lot of plant operations to produce things like plastics and ceramics, but lots of other things. So in chemical engineering, we need lots of heaters and coolers, and we need pumps to move fluid around or air around or other chemicals. And so many of these processes require the precise movement from one place to another to fill one tank, to empty that tank. And so what we'll do is we'll control those with electronic circuitry, most likely PLCs or programmable logic controllers. The programming of those, the maintenance of those, the maintenance of pumps, etc., is all under the realm of engineering technology. You have a much broader role in this whole scheme of manufacturing than the engineer or the scientist do. In civil engineering, you may be making sure that a retaining wall is being built to an engineer's specification, looking at plans and checking those sizes of the blocks, the footers, are they running straight? Are you doing some surveying work? That's a very popular field of engineering technology within the civil engineering realm. Or you may be testing concrete. As we pour concrete for a footer, we don't know if that concrete will hold up to the weight of the building because every pour of concrete is a little bit different because every mixture is a little bit different. So we'll pour a little sample of that concrete and we'll take it back to the lab and we'll put it in a big machine which will pull on it or more likely push on it to the point that it crushes. Through that testing, we'll know if the concrete that was used to pour the footer is strong enough to hold up to the weight of the building. All of that supervising the pour of the concrete, taking the concrete samples, testing them, is all within the realm of engineering technology. You guys, girls, are interested in advanced manufacturing mechatronics, so the electrical and mechanical probably are right in your wheelhouse. And along with that is this idea of industrial engineering. Industrial engineering is trying to optimize productions either to reduce cost, reduce materials, reduce time, make them more environmentally friendly, or make them safer. And all to do that requires the sort of orchestra of mechanical and electrical components all working together. The pumps, the controllers, all have to function properly and they all have to be maintained. That's all with the realm of engineering technology. You may not be designing it, but you are the one who makes it go. Since I've talked a lot about engineering, let's talk about engineering versus engineering technology. They are two separate things. Engineering is a calculus-based curriculum. It's usually seen as very theoretical, and if you were in engineering, you would probably transfer to a school like a Virginia Tech or a University of Virginia, University of Tennessee, or University of Kentucky to finish your degree, which would typically be a 4-year bachelor's degree. Within the technology realm, which is what you're in, you are probably in a more algebra-based curriculum. You're learning many more hands-on skills than an engineering student will learn. And you may decide to stop after 2 years and go out into the workforce, or you may decide to get a bachelor's degree in engineering technology uh, from a school that offers that, such as East Tennessee State University or Bluefield State. As you might imagine, the longer you stay in school, probably the more job opportunities and the higher pay that you can expect. But engineering's not for everyone. Some people really like to work with their hands, and therefore an engineering technology degree is well suited for them. A big part of becoming an engineer is the possibility that the particular industry that you work in may require the engineers to have a PE licensure. A PE licensure is is a statement from the state government that says you do high enough quality work, or you have the ability to do high enough quality work that uh, we as the state can trust you. Okay? To do that, your first task is to get a degree from an ABET accredited school. ABET stands for Accrediting Board for Engineering and Technology, and they accredit both engineering curriculums and engineering technology curriculums. Most all of the engineering and engineering technology curriculums that we have in this area and that you might think of are ABET accredited. So that's fantastic. ABET comes into a school that looks at their curriculum, their required the material covered in courses, the faculty expertise, and the lab spaces, and decides if that particular school's program is of high quality or not. And engineering and engineering technology schools take this very, very seriously, and they try to do their very best to ensure that they have ABET accreditation. You will have to get a 4-year degree in engineering or in engineering technology from an ABET accredited school to really start this process of becoming a professional engineer. The next step is within 12 months of graduation, you'll take the Fundamentals of Engineering exam. This is a very general exam that covers math and science and all the little different bits of engineering. It's looking for to test your skills that you understand just a little bit of all the different kinds of engineering. It's a day-long test, and can be a very good credential to have if you are interested in an industry that requires this PE licensure. If you have an engineering degree, then you work for 4 years with an engineer who can write letters of reference that says you've done the work of an engineer for the past 4 years, and then you can sit for your Principles of Engineering exam. If you have an engineering technology degree, then you'll need to work, go through the same process, except you'll need 6 years of work experience. If you decide to get your degree from a non-ABET accredited school or a non-engineering curriculum, then you'll need 10 years of work experience to go along with that, passing those tests. You can get more information from the DPOR Virginia Gov website. That's www.dpor.virginia.gov, where DPOR is the Department of Professions and Occupational Regulations. Once you get this PE licensure, then many other states will recognize you as being a quality engineer. So Tennessee, if you get your licensure in Virginia, Tennessee will recognize it, Kentucky, West Virginia, North Carolina, etc. And you can travel around to different areas. Is becoming a PE important to you? Maybe, maybe not. If you work under an engineer and that's your goal in life, as long as that engineer has a PE licensure, then you're fine. Then you don't need to get your PE licensure. However, if you want to rise up to be the same level as that engineer and have the same credentials, then you'll need to go through that licensure process. Some industries require the PE licensure, some don't. For instance, in civil engineering, you're doing many projects for, say, the state or federal government. You're designing buildings or bridges, so on. Before those projects are implemented, they must be signed off by someone that the state and federal government recognize as being a quality engineer. And so therefore they require a PE stamp of approval on those plans. Other industries, such as the automotive industry, they don't care at all about if you've got PE licensure. They just care about the quality of the work that you do. In terms of mechatronics and advanced manufacturing, I doubt you'll ever need to get your PE licensure. But in case you ever do decide to get your PE licensure, then you'll know some of the steps that are required to accomplish that goal. Well, that's all the information I have for you today. Thank you and have a great day.